Very good morning. Previous class we have discussed about vectors. In that vectors we discussed different types of scalar quantity and vector quantity, and we discussed different types of vectors also. Today we are going to discuss representation of 3-dimensional and 2-dimensional. So first let us start with the 3-dimensional. The vector representation, it is very convenient to express it in a Cartesian coordinate system. If you go for Cartesian coordinate system, so along horizontal is x-axis, along vertical y-axis, and another one is z-axis. Yes or no? And here we are introduced a unit vector. Unit vector, the direction of along positive x-axis I cap, and the direction along y-axis is j cap, along the direction of z-axis is k cap. So we are introduced a unit vector to representation of vector, that is along x-axis, y-axis and z-axis. Now let me write a vector based on the vector's law of addition. Before that we have to imagine vector A bar is coincide at the origin O. Let me imagine vector A bar is coincide at the origin O. Now let me write down the vector representation according to the vector's law of addition. That is A bar equal to x I cap plus y j cap plus z k cap. X I cap plus y j cap plus z k cap. This is the vector representation based on vector's law of addition. So coming class we discuss laws of addition, laws of subtraction. Now if you write the magnitude, of vector A, that is root of x square plus y square plus z square. Root of x square plus y square plus z square. Now let me write a unit vector of A. So unit vector of A is represented as A cap. That is, formula of unit vector is A bar by magnitude of A bar. A bar by magnitude of A bar. What is A bar? X I cap plus y j cap plus z k cap by, this is the A bar now according to vectors notation, and this is magnitude of A, that is root of x square plus y square plus z square. So whenever you ask that what is the unit vector of A means, you should write an A bar by magnitude of A bar, that is xi plus yj plus zk by root of x square plus y square plus z square. So up to now we discuss the vector representation Cartesian coordinate system, that is A bar and the unit vector magnitude of A bar. And now we can represent direction of cosines. Let, for example, now let me discuss the directions also. That is, if alpha will be making angle along x-axis. If for example this is x-axis, from A to B, x-axis is alpha. So making angle alpha with x-axis, beta with y-axis, and gamma with z-axis. So now if you want to represent the directions, if you make an angle alpha with x-axis, angle beta with the y-axis, angle gamma with the z-axis, then how we can write in terms of cosine? Let me do now. So we already know that according to the cos theta, cos is nothing but adjacent side by hypotenuse. So based on this, cos alpha is equal to x by, so if we take only these 2. So see here. This is opposite side, this is adjacent side. From here to here it is x-axis and this is magnitude of A. Magnitude of A is root of x square plus y square plus z square. So if you write in terms of direction of cosines, cos alpha is x by root of x square plus y square plus z square. Similarly, if we take y-axis, now here making beta na. Beta, angle beta makes with y-axis. So according to this, cos beta, adjacent side is by nana. Adjacent side is y by hypotenuse is root of x square plus y square plus z square. Okay, y by root of x square plus y square plus z square. And come to the cos gamma. Cos gamma is z by root of x square plus y square plus z square. So, if you want to represent in terms of direction of cosines, we already discussed. If we make an angle alpha with the x-axis, angle beta with y-axis, angle gamma with the z-axis, then cos alpha. We already know that cos is nothing but adjacent side by hypotenuse. So cos alpha is x by root of x square plus y square plus z square. Similarly remaining 2. So this is up to 3-dimensional. Next let me discuss a plane. Along the direction. If we consider plane means 2D. Let me discuss how we can represent in terms of 2D. Now, 2-dimensional representation. Two-dimensional representation. So here we are considered as plane. This is x-axis and this is y-axis. We already know that on x-axis, if the unit vector along the direction of x-axis we consider as I cap, along y-axis we consider as j. And here we need to imagine a vector a bar which is coincide of the origin. So this is vector a bar. So now if you write according to vector representation, that is x I cap plus y. Now we can write down the vector representation mark. That is a bar equal to x I cap plus y j cap. And how we should write the magnitude? Root of x square plus y square. And how we should write the unit vector? What is the unit vector of A? Unit vector of A we can write it as A cap. That is A bar by magnitude of A. That is x I cap plus y j cap by root of x square plus y square. Whenever if you represent the two-dimensional, one is along the x-axis, another one is along y-axis. X-axis is considered as I, y-axis is considered as j. Then how we can represent a vector? That is vector A equal to x I cap plus yj, and magnitude of vector A is root of x square plus y square. Then what is a unit vector? That is A bar equal to A bar by A cap equal to A bar by magnitude of A. That is xi plus yj cap by root of x square plus y square. Now let me represent the direction of cosines. See here, now here I am represented as a alpha. Along x-axis I am represented as alpha. Along y-axis I am represented as beta. Along x-axis I am represented as alpha. Along beta I am represented as beta. So now come to this cos alpha. See here. So this is adjacent side by hypotenuse. What it is? X by root of x square plus y square. X by root of x square plus y square, and If you come to the cos beta, if you take this side, so this is the adjacent side and this is the hypotenuse. Y by root of x square plus y square. So this is about representation of direction of cosine star. Yes or no? So from in this video we discussed about 3D and 2-dimensional representation of a vector. Thank you. Thank you.